This is Module 1, Lesson 11. In this lesson, we'll be using place value to fluently add multi-digit whole numbers and solve word problems. So we're going to start by looking at the problem of 3,134 plus 2,493. And we're looking for the solution of adding those two together to get a total. We're going to show this with what's called a tape diagram, which starts out looking like a piece of tape, long, skinny rectangle. And when we're adding, we're taking two or more smaller pieces and combining them together to make a larger piece. So we're going to divide our tape diagram. We'll make the side for the 3,134 a little bigger than the one for 2,493, since we know it's a little bit bigger. And we put a bracket to show the value of each one, and then we put a big bracket at the top and a question mark, because that's the value we're looking for. That's our unknown, and that unknown is called a variable. So we're looking for the solution to this. We're visually showing it with a tape diagram. And now I'm going to draw a place value chart to show this. And I can see that both of my numbers go to the thousands place, so I don't need to draw a full place value chart. I can probably get away with just drawing to the thousands. And I'm going to show the first number that we're adding, the first addend, as 3 thousands, 100, 3 tens, and 4 ones. Then I'm going to show the second addend as 2,000, 4 hundreds, 9 tens, and 3 ones. And now I'm going to start combining these together, starting with the ones place and regrouping and exchanging for the next highest value once I have 10 of the same unit. So in the ones units, I have 7 ones, which is not enough to exchange for a higher value, so I'm going to stay with 7 ones. Here I have 9 tens plus one more would be 10, so I can exchange that for 100, leaving me with 2 tens, which is 20. Then in the hundreds, I have 4, 5, 6 hundreds, again, not enough to exchange, so that value stays as 600, and in the thousands, I have 5 thousands. So I get an expanded form here, and I can see that I have 5,627 as my total. So my variable up here, my unknown, would be 5,627. So I've shown my problem 3 ways. I've shown it as an equation. I've shown it as a tape diagram. I've shown it in the place value chart, and I've written it in expanded form. Let's try another one. This time I'm going to write the problem vertically. 40,762 plus 30,473. And I'm going to show this in a tape diagram. Again, I have 2 parts, and I'm looking for the whole. So I'm going to show my first part and my second part. And my unknown is the whole total. And then I'm going to show with a place value chart. So these are my ones, tens, hundreds, thousands, and 10,000s. And I'm going to show my first add-in. I have 4 10,000s, no thousands, 7 hundreds, 6 tens, and 2 ones. My second add-in, I have 3 10,000s, no thousands, 4 hundreds, 7 tens, and 3 ones. And again, I'm going to start combining now. So 2 tens plus 3 tens is 5, ones. 2 ones plus 3 ones is 5 ones, not enough to exchange. Here I have 6 plus 4 more gives me 10 that I can exchange for 100. So now I have 1, 2, 3 tens left. Then here I have 7, 8, 9, 10 hundreds that I can exchange for 1,000, leaving me 2 hundreds. I now have 1,000, and I have 7 10,000s. So now I've written this in standard form, and my solution is 71,235. Now I'm going to go back over to my original problem, and I'm going to do this another way, which is what we call the standard algorithm. So we're doing exactly what we're doing in the place value chart, but we're doing it without drawing the place value chart. So I'm going to start with the ones, just like I started with the ones in the place value chart. I had 2 ones and 3 ones, so I had a total of 5 ones. Then in the tens, I had 6 tens and 7 tens, so together that was 13 tens. But again, just like I did in the place value chart, I'm going to take those 10 tens and turn them into 100. So I'm going to put that 100. This that I did here and moved over here, that one, that's what I just did here in the standard algorithm, which leaves me with 3 tens here. So 13 is the same as the 3 tens I had left here plus the 1 10. So now I have 7 hundreds plus 4 hundreds plus 1 more 100 would be 12 hundreds. And again, 10 hundreds is equal to 1,000, leaving me with 2 hundreds here. Now in the thousands place, I have 0 plus the 1,000, and 4 plus 3 is 7. So tape diagram, place value chart, standard form, standard algorithm. Okay, let's try another one. This time, let's visualize the place value chart, but not actually draw it. So let's write this addition problem. Okay, so we're going to start with the ones place. So we have 6 ones plus 4 ones is 10 ones. I can exchange the 10 ones for 1 10. I'm going to put it here, which doesn't leave me any ones. So here's 10. Then I'm going to do 2 tens plus 4 tens is 6 tens plus 1 more 10 is 7 tens. Not enough to exchange. 4 hundreds plus 7 hundreds is 11 hundreds. So I'm going to take 10 of those hundreds to make 1,000, leaving me with 100 here. Then I have 7,000s plus 8,000s is 15,000s plus 1 more is 16,000s. I'm going to exchange 10 of those for a 10,000, leaving me 6. I have 0 10,000s plus 2 10,000s plus 1 10,000s gives me 3 10,000s. And I have 200,000s plus 100,000 gives me 300,000. So that would be my solution. This is the standard algorithm. Now, some of you may be used to putting, if this is 6 plus 4 tens, of putting the 1 up here. But sometimes it's easy for our eyes to forget it if we write it way up here. So if you write it right on the line here, you're less apt to lose track of it. So the 6 tens plus 4, the plus 4 tens is 10 tens. So we're writing the 10 like this. Okay, let's use this to solve a word problem. So the Lane family took a road trip. In the first week, they drove 907 miles. In the second week, they drove the same as the first week, plus an additional 297 miles. So the question is, how many miles did they drive the second week? And remember, when we're writing a word problem, when we're solving a word problem, we need to solve the problem with numbers, but then we need to answer the problem in a sentence. So we're going to practice what we've been doing, which is to start with a tape diagram to visualize our problem. So for the second week, they drove as far as they did the first week, which was the 907 miles. And then they drove another 297 miles, and we want to know how much they drove altogether. So our variable miles is unknown. So we're now going to turn our visual drawing into an equation. So we have 907 plus 297. If it helps you to draw the place value chart, as opposed to just doing the standard algorithm, by all means go ahead and do that. If you can visualize the chart and do it with the standard algorithm, that's great. So we're going to start with the ones. We have 7 ones plus 7 ones is 14 ones. 0 tens plus 9 tens plus 1 10 is 10 tens. So we're going to exchange for 100. 900 plus 200 plus 1 more 100 is 1200. So 200s and 10 tens becomes 1,000. So we would answer the question is, they drove 1,204 miles the second week. And this strategy for solving word problems is called the RDW method, where R stands for read, to read the problem carefully and make sure you understand what it's giving you and what it's asking you. Then we're going to draw a picture of it. That's where we use our tape diagram. And then we're going to write first the equation, and then we're going to write a sentence to answer. So RDW, read, draw, write. We're going to use that every time we see a word problem. So let's practice some with a lesson 11 problem set. So here's a series of problems, and it says to use the standard algorithm. Again, if you can't reliably use the standard algorithm and you need to draw a place value, use your place value chart, you can do that. But the 4th grade standard is to be able to solve addition and subtraction problems using standard algorithm. So pause the video and try A. Okay, so for A, we have 2 plus 8, 1 plus 8 is 9. 1 plus 6 is 7. 3 plus 200s is 500s and 6,000s. Pause the video and try B. Okay, for B we have 9 ones, 7 tens, 500s, and 7,000s. Pause the video and try C. For C, we have 12 ones, 8 tens, 500s, and 7,000s. Pause the video and try D. For D, we have 7 ones, 10 tens, 800s, and 8,000s. Pause the video and try E. For E, we have 7 ones, 10 tens, 800s, and 10,000s. Pause the video and try F. For F, we have 11 ones, 14 tens, 800s, 7,000s, and 1 10,000. Pause the video and try G. For G, we have 16 ones, 14 tens, 100, 8,000s, and 5 10,000s. Pause the video and try H. For H, we have 8 ones, 13 tens, 15 hundreds, 6,000s, and 10,000. 10 10,000s, which would be 100,000. Pause the video and try I. I, we have 6 ones, 5 tens, 12 hundreds, 11 thousands, 10 10,000s, and 900 thousands. Pause the video and try J. Okay, for J, we're gonna write the numbers vertically, and this time we're adding together 3 numbers. So we have 7 plus 5 is 12, plus 2 more is 14 ones. Then we have 2 plus 7 is 9, plus 5 is 14, plus 1 more is 15 tens. And then we have 5 plus 2 is 7. 7 plus 7 is 14, plus 1 more is 15. And we group for 1,000. Try the same thing for K. Okay, once again, we're going to write our numbers vertically. Make sure you line up the place values, so all the commas should be lined up. So we make sure we're adding together the correct units. So here when we add together the ones, we get 3 plus 6 is 9, plus 1 more is 16. Here we have 9 plus 1 is 10, plus 12 is 22. So we have 4 plus 3 is 7, plus 1 is 8, plus 2 more is 10. Then we have 8 plus 6 is 14, plus 2 more is 16. 3 plus 4 plus 1 is 8 10,000s, and finally 200,000s. Okay, now we're going to go on and use these to solve some word problems. So it says to draw a tape diagram, and then you use numbers to solve and write your answer as a statement. Okay, so for number 2, pause the video and solve that problem using a tape diagram and answering your final question in a complete sentence. Okay, so we see we're going to start with a tape diagram. And we have two parts to add together. Lincoln Elementary collected 32,537 cans for a fundraiser in September. And then in October, they collected 207,492 cans. And the question is, how much did they combine all together? So I'll do C to B. Cans are unknown, are variable. So we're going to set this up vertically as an addition problem, making sure that we're lining up our units. And the easiest way to do that is to line up your commas. So we're going to add 7 ones plus 2 ones is 9 ones. 3 plus 9 is 12 tens. 5 plus 4 plus 1 is 10 hundreds. 2 plus 7 plus 1 is 10 thousands. 3 plus 1 is 4 10,000s and 2 100,000s. So we'll answer, they collected 240,029 cans. Okay, moving on, try 3 by yourself and then we'll check it together. Okay, again, we're going to start with a tape diagram. And we've got some cheeseburgers and some burgers without cheese. And we want to know how many they sold in all. So we'll do B for burgers, and we'll write our addition problem vertically and add 6 plus 9 ones is 15 ones. We have 8 tens. 8 plus 6 hundreds is 14 hundreds. And 2 plus 1 plus 1 is 4 thousands. So they sold 4,485 burgers. Okay, pause the video and try number 4. Okay, here we have our tape diagram again. We saw how many people attended the concert on Saturday night, which was 23,748. And reading this carefully, on Sunday, 7,572 more people attended. So this is how many more they attended on Sunday than on Saturday. And then the question is, how many people attended the concert on Sunday? So we'll line this up again vertically, lining up our place values, making sure we're adding together the same units. So 8 plus 0 ones is 8 ones. 4 plus 7 tens is 11 tens. 7 plus 5 hundreds plus 1 more is 13 hundreds. 3 plus 7 plus 1 is 11 thousands. 2 plus 1 10 thousands is 3 10,000s. So 31,318 people attended on Sunday. And that's the end of lesson 11.